I'm going to cover project concepts as well as some technical things. So like Calvin said, feel free to raise your hand along the way, and let's make this as interactive of a discussion as possible. So I'll jump in. You heard a little bit about my background. I'm been at P3 Mobility for about 4 years now, and P3 Mobility was founded in 2018, and we're headquartered in Ann Arbor, Michigan. And our goal is to help expedite the adoption of V2X and connected vehicle technology as much as possible. So we do that by providing a software platform that helps manage V2X operations and messages, as well as consulting services to help plan and execute on deployments. P3 Mobility is involved with a couple of projects around the country. So the two that we'll focus on today are going to be the Smart Intersections project in Ann Arbor, Michigan, as well as the Road Commission for Oakland County Smart Grant Stage 1 project. P3 Mobility, though, has also been involved in the Henry County V2X Smart Grant project down in Georgia. It's a suburb of Atlanta, as well as we were one of the members of the team that was awarded the Maricopa County Saving Lives with Connectivity grant, which is one of the special V2X grants that the USDOT announced last year. I want to start by just highlighting that Michigan is really a leader in this space. They're always at the forefront of research and deployment for V2X, connected vehicle, autonomous vehicle technologies. I think everyone here knows that. One of the things that I want to highlight that I think is really interesting is how the projects in Michigan have really iterated on each other and have evolved over the years. And that's starting all the way back with the safety pilot model deployment in 2012, which really laid the foundation. That has since been expanded through the Smart Intersections project, and even the more recent Attain project through the University of Michigan. And then P3 Mobility has worked with the Road Commission for Oakland County to expand upon those projects even further in the project that's called Leading in Sustainable Safety. And that project started early last year and has been underway. And I'll talk about each of these projects a little bit more in depth throughout the way. Starting with the Smart Intersections project, I just want to give a quick overview of the project concept and the status. So this project's goal was to seek ways to accelerate nationwide adoption of V2X technology. And there was a couple different ways it tried to achieve that. First, it wants to ensure wide-scale benefits of CAV infrastructure are present without wide-scale adoption. So this is looking at how things like sensors at the intersections can help complement vehicle-to-vehicle communications. It's also looking at how revenue generation can facilitate investment needed to help fund and build out the CAV infrastructure. And then lastly, it's looking at how to help inexperienced public entities go through the entire process of building, planning, financing, and deploying this type of technology. And that's being done through the publishing of what we're calling an implementation guide, which is a document that walks IOOs through these various topics. In terms of use cases, for this project, there's two that I'll highlight. The first is VRU alerts. So this is using cameras and sensors at the intersections to identify and detect pedestrians, and then broadcast that information to vehicles through sensor data sharing messages. The other use case that is being deployed is transit signal priority with the bus fleets in Ann Arbor. And in terms of current status of this project, the V2X hardware has been deployed in the field, and we're doing some pretty extensive testing before turning it on with all the buses. So you could think of it as more advanced than bench testing, but not quite at field testing yet. For the other project, the project in Oakland County, this was a stage 1 SMART grant. So it's the first stage of a 2-stage program where the goal was to develop the plan to deploy V2X technology across Oakland County, as well as to demonstrate this technology in a prototype. So there was a couple different objectives. First, it was deploying at 5 intersections. Second was developing a comprehensive plan for deploying across the county. Third was creating a public-private partnership model that includes revenue generation. So that's a carryover from the Smart Intersections project. And then the fourth piece was planning for workforce development and community engagement. And these were elements of the project that were required by the SMART grant program. And we actually undertook a pretty extensive community engagement process where we had a group of stakeholders on an advisory board that were helping come up with the right community stakeholders and messages to share with the community for once this project is ready for wide-scale deployment. In terms of use cases are V2X safety alerts. So we will be doing VRU alerts similar to the SIP project, and then we will be doing it's called freight signal priority, but it's with the RCOC maintenance vehicles to test out signal priority and help the maintenance vehicles in the county get some additional extended green time. And so status for this project, the V2X hardware is deployed at the 5 intersections, and then field testing is in progress, and we're doing a lot of data collection and analysis to submit the final report to the US DOT, which is coming up here in February. So one of the themes that I talked about that covered both projects was this idea of V2X revenue generation and sustainable funding. So I want to talk a little bit more about what that actually means. And to do that, I want to start by just defining what does sustainable funding and financing mean. And so there's 4 pillars that I like to talk about that make it sustainable. First is it's predictable and recurring. You can depend on it. Second is it's substantial. So it's meaningful and large enough to do something with. Third is it's long-term and able to sustain a program over a period of time. And then fourth, it's at a competitive market rate. So you can think of this as an interest rate or what the cost is to access that funding. And typical funding options that are available to IOOs are usually grant funding, whether that's formula funding or discretionary grants. There's also debt funding, which is by issuing bonds or getting a loan. And then the last is a P3 or private investment, which is what I'm going to focus on here today. And all of these funding options have pros and cons. For example, grant funding could be very substantial. However, it may not be predictable if you're relying on discretionary grants. Alternatively, debt funding, might be very predictable and recurring, but the competitive rate on the interest rate on those may not be appealing depending on what the market conditions are like. Next is, why do we care about funding being sustainable, and why do we need to worry about finding other ways to fund these projects? Well, the data shows that, and I'm sure that we're all aware of this, that the gas tax revenues are no longer going to be sufficient to fund all of the transportation needs in the nation. And there's projected to be a $280 billion shortfall through 2034. So, if IOOs are trying to prioritize how they use their funding, they may not be able to prioritize advanced technologies like connected vehicles because they will barely have enough funding to cover their other operational and maintenance needs. Next, in addition to this lack of funding, the US DOT has released their V2X deployment plan, which has some pretty aggressive goals. They have provided some small funding amounts in the form of the Saving Lives with Connectivity grants. However, there's a lot more funding that's needed if they want the nation to truly hit the goal of having 85% of signalized intersections with V2X by 2036. So that's where this idea of other sources of funding and private investment come in. And so I want to talk quickly about what does private investment mean and what does that usually look like. And so you probably think of private investment in the transportation space when you think about toll roads or bridges, where there's a private entity that builds and maintains and operates that facility, and then they're getting their investment paid back through the fees that they're generating from their users. But traditionally, that's been strictly for roads and bridges. However, recently we're seeing this expand more into the digital infrastructure space. So things like wireless and telecom and data centers are becoming more and more interesting for private investors to get involved with. So the benefits of private investment are that it hits on those 4 pillars that I talked about previously: predictable, recurring, long-term, substantial, and provides competitive market rates. It also provides another benefit in that a lot of times these projects and deals are structured that the private sector expertise is being brought to the table, and it's helping to execute on the project, especially for advanced technologies where an IOO may not have the right workforce and skill set in order to deliver on those types of projects.
Mm.
And I think it's important to note that when I talk about private investment or a P3, there's a lot of different ways that could take shape. There's a lot of different ways that could look and be structured. So the concept is one thing, but within that, there's a lot of there's a wide spectrum as well. So what does this look like in the real world for a V2X project? Well, the way that we're envisioning it now is this cycle that I'll show here. So step one is a public and or private partner is funding some initial V2X infrastructure. Maybe it's a combined funding of infrastructure from both partners. And from there, all vehicles are getting access to some core safety applications. But then some vehicles are subscribing and paying to have access to premium V2X services. What defines a core versus a premium service depends on the specific IOO and their policies. But a premium service might include something like freight signal priority in an industrial shipping corridor. It could mean access to some enhanced V2X data. It could be certain types of safety alerts are on a subscription basis. But whatever the breakdown is, the idea is that the fees that are collected from those services are used to pay for the O&M, the expansion of the system, and potentially pay back the initial investment costs from a private partner. And so that's very similar to the model I talked about previously with a toll road, where there's a revenue stream to pay back the construction of the infrastructure. But the idea is that value add V2X services are being provided on this subscription basis to incentivize adoption. Vehicles are going to be excited to subscribe and adopt the technology. And then this funding is going to offset the CapEx and OpEx of the V2X infrastructure, which, as we've already established, is not within typical budgets of IOOs. And the other thing, this just highlights again what I talked about previously, this type of arrangement is going to have a very wide spectrum. There might be public agencies that want to do it all themselves. That's been the case so far in a state like Utah, where they've had a lot of success deploying V2X projects with their own funding. And on the opposite end is what's called a revenue risk P3, which is where everything is on the private partner and there's just an agreement with the public agency to operate the system on the public agency's behalf. Many of these will fall somewhere in between, and it's really up to the goals and objectives of the public agency to decide what's right for them. And you might ask, how does this work at a technical level? So I'll talk about a couple things on this architecture diagram. So this diagram is kind of like a generic diagram that could be used for either the SIP or RCOC projects with a couple of minor modifications. But the key piece of this diagram is at the bottom, which is the P3 Mobility V2X authorization server. So this is a server that's part of the ecosystem. It's enrolled in SCMS. And every time a vehicle requests access to a specific service, for example, signal priority, this server is checking to make sure that that vehicle is authorized for that service, whether it's that vehicle has an active account, whether it's the location of that service, the time of day. There's a lot of different factors that can go into it, but ultimately it's doing the accounting for that vehicle to make sure that they're authorized for that specific service. And if the vehicle is authorized, then it authorizes the service and the vehicle has access to whatever that service may be, signal priority, etc. The reason it's important that the authorization server is enrolled in SCMS is that it helps protect the identity and sensitive data of the end user. And it also makes the system interoperable with deployments. As long as SCMS is in place, which it should be for all V2X deployments, the approach in the system would work effectively. Next, I'm going to move into some other technical approaches and unique things that I will call out about the projects. And so first, I want to talk about the VRU detection approach. So this is a a picture from inside a cabinet that shows a different hardware that's in place. So mounted at the intersection are GridSmart cameras. Those are connected to a GridSmart processor box, which is then in turn connected to a separate edge processor box that is running P3 Mobility software, as well as University of Michigan's MSite software, which is doing object detection and detecting and locating the VRUs. There's also a wireless modem in the cabinet and a Econolite controller to go along with a CODA RSU that's also mounted on at the roadway at the intersection. And so what we're able to do is use the cameras, use the MSite algorithm to detect pedestrians, and then P3 Mobility converts that into a J3224 sensor data sharing message, which is then broadcast to vehicles. And so this diagram here is a plot of the objects that have been detected. So the blue objects are vehicles. You can see those are traveling nicely down the road. And then the red objects are pedestrians. You'll see a big sea of red just above the road. That's because this is a school and that's a playground. So it's identifying all of these pedestrians, even though they're not in the road. Those alerts are not being sent to vehicles. It's only if the VRU is in the roadway. But you'll see that in the zoomed in photo here, there's a crosswalk. You can see where pedestrians are frequently traveling. So this is just kind of a summary of the information that's being collected and broadcast. An interesting learning is that the machine learning models and configuration have improved over time. So you'll see on the left side here, there was a configuration issue where the X, Y axes were not calibrated correctly. That was an easy fix. And then on the right side, you'll see there's, as you get further away from the intersection, it doesn't look like individuals are on the sidewalk or vehicles are coming off the road. So that was a model training and another calibration issue that was resolved. But I think it's important to know that these types of things take iteration and they take training data to improve them over time and make them as best as possible. Here's another one that's interesting too. So after we got the model calibrated, we sent someone from our team out to do this zigzag walk, and they were tracked, very accurately for almost the entire way, except there was a big blind spot in one corner of the intersection. Well, when we looked at the video feed, it turned out that there was actually a smudge on the lens, so that was what was preventing the detection in that area. But this is an example of a real world scenario that we didn't think about at first, but we need to be able to think about and address. And maybe it means that cameras shouldn't be the only thing that are relied upon. We're also exploring the use of LiDAR and radar and combinations of sensors in order to avoid this type of scenario. But I think in general, any type of sensor that's out there is going to require some type of maintenance. When it comes to the driver display approach, after the sensor data sharing message is generated, we wanted to display the alert to the driver on a tablet or some type of display in the vehicle. We feel that in the future, OEMs are going to design their own displays and alerts into the vehicle. So this had to be something that was separate for now, and we would use an aftermarket display. But what we did is we designed images that show the location of the VRU, and then there's 3 different levels of alert. So level 1 was just awareness, meaning, hey, there's a VRU somewhere, you don't need to worry about them. Level 2 was, hey, there's a VRU somewhere where they're not supposed to be, whether they're jaywalking when they don't have the walk sign, or maybe they're in the middle of the intersection or outside of the crosswalk. And then level 3 was critical warning. There's potential for an impact, and that was determined by comparing the time to collision with the time to stop based on the vehicle speed. And so we wanted to be able to differentiate the 3 different levels of severity of an alert, so that the driver wasn't getting bombarded with information that they did not need to take action on. Another thing that we really wanted to show was the granularity of the data. So we're getting very granular data for locations of the pedestrians. We wanted to be able to show what was possible with this data. So we came up with different images to show where they were within the specific crosswalk. Instead of showing just a generic alert that there's a pedestrian, we want to show where exactly they are. And then In the future, we want to get even more granular besides these 4 images to have it be more dynamic, similar to if you've driven in a Tesla, you could see the sensor display where it's actually in real time. We're envisioning something very similar, but with V2X data as opposed to the sensor data from the vehicle. Another thing to share is that V2X data obviously is not always available when you're not in range of an RSU. Since this was only a 5 intersection deployment, if you were driving around, you would get the system not available at this location message most of the time. If there was if you were near an RSU but there was no pedestrian, you would just get a blank intersection image. Obviously, that's not the best for user experience. I think it works to demonstrate the technology and show what's possible. But in the future, this would be merged into some type of mapping feature or built-in infotainment system of the vehicle. Another concept that I want to touch on is the difference between direct and network V2X. So direct V2X is vehicle to vehicle or direct vehicle to infrastructure using the 5.9 spectrum over previously DSRC technology and now CV2X technology. This is what provides the really low latency communication for the safety critical alerts. And this is what our focus has been on to date. However, the networked V2X approach, which requires an existing cellular network to be an intermediary between the devices, is something that is gaining some momentum in the industry, I would say. And so I haven't seen anything that shows that the latency is low enough to do safety critical applications through network V2X, but I think it's going to be good for things that are not as time sensitive. So maybe that's a map file, or maybe that's a weather alert or a work zone alert where it's not something that you need to take immediate action on, and you have a couple seconds to get that communication as opposed to milliseconds. But this is something that we are interested in exploring in a future stage of this project to see how they could work together. One of the big hurdles is interoperability. How do we make sure that messages are trusted, whether or not they're coming from direct or network V2X? So I would love to see SCMS be deployed on the network V2X approach, but that's, again, something we haven't seen yet today. In addition to those two approaches, I do want to talk about another concept that helps us deal with the challenges in the limited 5.9 gigahertz spectrum. So everyone here probably is aware that a couple of years ago, the FCC reduced the available spectrum in the ITS band and took over half of the spectrum and made it unlicensed. ITS America published a document shortly after that said that some message types and applications would not be able to be supported over the remaining amount of spectrum that was available. Specifically, they called out cooperative perception messages or sensor data sharing messages, the same messages that I was talking about we were using in these two projects. These are really the messages that are going to support advanced features in autonomous driving. And like I said, the LTE and 5G networks have not really shown the latency is low enough yet to support these messages. So we thought it was important to look at ways to get around this lack of spectrum. And so what we ended up demonstrating is that how V2X messages can be sent in that unlicensed band, also called the uni bands, and actually using DSRC technology to do so. So the units that we were using in the project in Oakland County were both dual mode V2X and DSRC. They have two separate chips. We were using the CV2X chips, but then the DSRC chips were just sitting there not being used. After working with the vendor, we realized that we could change the spectrum that the DSRC was broadcasting on to move it away from the ITS 5.9 spectrum and into the uniband spectrums. So basically what you're doing is you're using the same communication protocol, but just sending it over a different wavelength. This is in line with the most recent FCC rulings because they said that DSRC needs to stop operating in that 5.9 spectrum, but there's there's no rule preventing it from operating in the unlicensed spectrum. So there's actually a very wide range of spectrum that's available. There's unis, bands are broken up into these different Uni 1, Uni 2, Uni 3. And so we are currently demonstrating how V2X messages can be sent in Uni 1, 2, or 3 bands. And then in the future, we will support bands 5, 6, 7, 8, but that just requires some different hardware enhancements right now. And so, some other unique things that I'll call out about this, we really wanted to control who had access to that band, because in reality, these are Wi-Fi bands typically, and the home Wi-Fi or Starbucks Wi-Fi is likely using these Uni 1, 2, and 3 bands. And so what we did is we controlled who accessed this network by encrypting the network key, or basically the Wi-Fi password, with SCMS, so that only vehicles with V2X OBUs that are enrolled in SCMS can decrypt it and get that password and access the network. And we recycled the passwords every 10 minutes. We made it an automated process so that the user has to do nothing. The vehicle is in the OBU is doing it all on its own. But that was really important for us to limit, other potential users of the network, or if there was only one password that was never changed, having somebody be able to use that for other purposes. Another thing that we wanted to demonstrate is related to interference. So one of the pushbacks that people in the industry have had on using these uni bands is that other people are using it. It's not reliable for V2X messaging. So what we did is we created a schema where we dynamically switched to different parts of the uni bands based on the interference that we were detecting at that time. We actually didn't detect very much interference out in the roadways. We must have been far enough away from building or home internet routers where it wasn't a problem, but we were able to successfully demonstrate this and actually broadcast these SDSM messages in this unlicensed uniband spectrum. A couple other lessons learned and next steps that I want to call out, because I think they're important for any V2X in ITS deployment. First is that the IT networks and the firewalls were the biggest cause of delays. Took a lot for us to be able to connect to the RSU from the cloud or from the TMC, and I think that's a good thing. I think these networks are secure, but I think it takes a lot of work, and there's a lot of different stakeholders involved for different parts of the network who needed to get together in order to find a solution that allowed the connectivity to be created. Another challenge was adaptive traffic systems are challenging, especially when you're working with signal priority. SCATS, which is present in Oakland County, has agreed to partner on the next stage of the project to figure out a way around some of those challenges. But for the first stage, we purposely avoided locations that had SCATS running, so we didn't have to worry about that. And that was true for the SIP project as well. Another thing that we are thinking about is how to cover multiple intersections with one RSU. In Oakland County, there are many locations where there are several intersections within 100 and 200 meters, which is well within the 400 meter range of an RSU. So we want to explore sending messages from both, or from multiple intersections from just one RSU. And the messages would be differentiated based on the intersection ID and the map file. So we think this is possible, and it's something that we're planning to explore later this summer. And then the last thing I'll mention here is that we did use some remotely managed power strips, and that helped a lot with troubleshooting. So these were power strips in the cabinet that had an internet connection, and we could remote in and recycle a certain plug if we saw that the RSU was down or if the edge device was down. We also set up rules to automatically cycle if we were unable to ping a device after a certain set period of time. So this is just a small thing that ended up helping us in the long run, and it's a pretty easy thing to incorporate in other projects that you might have going on. And then my final takeaway is that it takes a team to deliver these projects. There's not one firm that is able to cover hardware, software, project management, engineering, installation. So, I would encourage everyone to just continue to make connections in this industry. If you have questions on any of this, feel free to reach out to me. I'm happy to share more information or collaborate and share other best practices that we've learned. And I'm excited to hear from others if you have other lessons learned to share. So with that, that's everything I've got. And if anyone has any questions, I'll happily answer them.
Thank you for your presentation, Jeremy. I appreciate it. We did get one question in the chat while you were presenting. Wondering if you'd be willing to share the slides following this session.
Yeah, I can coordinate with you to do that. You can send it out, Kevin.
Yeah, that's perfect. So yeah, if folks have any questions on the call, please feel free to raise your hand or just unmute and ask Jeremy your questions. Go ahead, Sridhar.
Hi, Jeremy. Thanks for sharing your insight into these deployments. Can you talk a little bit more about the monetization of this, what you call a subscription service and a basic service, please?
Yeah, so for both of these projects, there's not actually any subscriptions being offered. There's no money changing hands. It's more so validating that the technical approach of using the authorization server works for the use case of signal priority. And so in the RCOC project, we have also been engaging with fleets within Oakland County, garbage fleets, maintenance fleets, FedEx, Amazon, those type of folks, to understand how they're thinking about this and if they would be interested in subscribing. And so those conversations are ongoing. And if and when the RCOC project gets the stage 2 funding, then we would explore offering this on an actual subscription basis.
And sorry to again ask a follow-on question. So for a fleet operator, for example, the value proposition would be that they would get more time at an intersection to make their turns or go through, or they'd get priority if they pull up to an intersection, they don't have to come to a stop, or all of the above?
Yeah, that's the idea. What that exactly translates to is going to be dependent on the policies and the timing plans that the controller has, how much time they're willing to extend the green time. Right now, it's very conservative. It's just a few seconds. I think it's up to 8 seconds that it would be extended in the prototype, but that can vary based on the location and in other factors as well. Did that answer your question?
Yes, very much so. Thank you.
Okay.
Any other questions from folks on the call?
I have one more, Calvin.
Yeah, go for it.
Have you benchmarked these what you call delays? Delays authenticating a subscriber onto the service, and then any type of delays that might pertain to that might have an impact on how quickly they receive messages with respect to safety. Over.
So you're asking, does this authorization step add time to the overall message broadcasting process, correct?
That's part A, and yes, part A, and part B is there any system delay that compromises how timely that safety message is with respect to especially a pedestrian?
Yeah, so I don't have the numbers for you right now, but from what I've heard from my team is it's a couple additional milliseconds. I think for the use case of signal priority, that's not a huge challenge or burden because that's usually requested several seconds out. But we have not done that authorization step for safety messages, SPAT or BSMs at this point.
Thank you.
Last call for questions. Anyone online have a question for Jeremy?
And
All right, well-
if you don't want to ask now, feel free to reach out. My email's on the screen, so I'm happy to chat offline as well.
All right, I think with that, we'll end today's session. So I want to thank you, Jeremy, for joining us again. Oh, actually, it looks like we do have a question.
Real. Yeah,
Go
this
for
is
it.
Santosh. I was curious where the map file lives. Is it going to be in the controller or the RSU or the P3 device?
So in the RCOC project, it is in the P3 Mobility Edge device. In the SIP project, it's in the RSU. So I think there's flexibility for different deployments there.
Any recommendation on where it needs to be?
I don't think so. So, the map file is pretty, it doesn't change very often. So I think there's not a huge sense or a huge need to have it in a certain location. It gets broadcast 1 time per second. So I think any of those options are feasible, just depending on the architecture of the system and the network.
Okay, thank you.
All right, I think with that, we'll end today's session. So thank you again, Jeremy, for joining us. And we hope you join us for the next Lunch and Learn session. We'll be sending an email about that once we have it confirmed. If you want to learn more about P3 Mobility or the Smart Intersections project, you can find the links to those in the chat. And I hope you all have a great rest of your day. Thank you.
Thanks, everyone.
Thanks, Jeremy.